Hello, it's time for Ocho, the 8th homework lecture on chemical bonding. We're going to hit up bond type and the physical properties. So you're going to do a lab on these physical properties of ionic versus covalent compounds, and here's the lecture that kind of goes with it. Because the type of chemical bond between atoms determines the physical and chemical properties of the compounds that have been formed. Ionic bonds yield ionic compounds which have ionic properties. Covalent bonds yield covalent compounds which have covalent properties. And getting to know the stark differences between these two classes of compounds is what this lecture is all about. So at the end of this, I want you to be able to say, I can tell you the properties of ionic versus covalent compounds, and therefore identify them when you're in a lab setting. So the 4 properties that we hit up are solubility, conductivity, melting, boiling point, and structure of the crystals. So physical properties of ionic compounds. These are mostly soluble in water. There are always exceptions to these chemistry rules, but they are soluble in polar solvents. Water is a polar solvent. We're going to hit up polar, nonpolar in the last couple lectures of the video of the series here. So ionic compounds do dissolve in water to some extent. Conductivity. Well, ionic compounds allow the solutions to be conductive of electricity. They're not conductive in their solid forms, but if you were to melt them down to make molten salts, ionic compounds, they would conduct electricity. So conductivity of electricity depends on if it's dissolved in water. If it does dissolve and it is ionic, it will let the water conduct electricity. End of story. Melting and boiling points of ionic compounds. These typically have very high melting points and very high boiling points because the attraction between the positive and the negatively charged ion is extremely large. So these atoms, or rather ions, want to stay stuck together. And to get them to melt and boil, we have to push them apart. So they want to stay stuck together, and therefore they have high melting point and high boiling points because of their ionic character. Crystal structure. Ionic compounds form beautiful, beautiful complex crystals. They are usually very hard and will fracture. So crystal structure, hardness, and fracture are all related to mineralogy, earth science concepts. If you want to think of a connection between ionic compounds and earth science, think minerals. All minerals are ionic compounds. Rocks are just collections of different microcrystals of minerals. So crystals, ionic. And we go forward. Covalent compounds. Well, they are slightly soluble in water. They are soluble in nonpolar solvents. So basically, solubility is not the rule of thumb for covalent compounds. Many do dissolve in water, many do not. So if you're asking yourself, is this ionic or is it covalent? Let me dissolve it in water. Might not give you the be-all, end-all answer. You might have to do some of these other tests too, like conductivity. This is a be-all, end-all for ionics versus covalents, because no matter what you do, a covalent compound will not conduct electricity in solution or as a solid form. There are, of course, some exceptions to the rules, as I mentioned before, but we're not going to go into those. Covalent compounds, by rule, do not conduct electricity. There's no positive and negative ions to move around, so they can't conduct electricity. Melting and boiling points. This is another good one to use as a rule of thumb. The majority of covalent compounds have low melting points and boiling points because the molecules of covalent compounds do not have positive and negative charges that attract them to each other. So these molecules are not actually sticky for each other very well. They have very weak forces of attraction between them, and therefore it's easier to get them to spread apart and turn into a liquid, and spread apart more and turn them into a gas by adding just a little bit of heat. So covalent compounds have low melting and boiling points. Crystal structures. While you can get a lot of stuff to form crystals, and there are some covalent compounds that do crystallize, most of them are non-crystalline in structure. They don't fracture, and they're relatively soft. So they're opposite of ionics, really, and that's what I want you to remember. Ionics do a certain set of things. Covalents do pretty much the opposite. And that's set of things, conductivity, solubility, melting point, and crystal, you can use to figure out, yeah, this stuff's probably ionic, or this stuff's probably covalent. And that would be the point of our lab. The last class of compounds is the metallic compounds. These are really more like alloys, should be the word used here to describe a metallic compound. Solubility-wise, they don't dissolve in water. Metals don't dissolve in water, period. Conductivity. Metals do conduct electricity and heat as solids, and as liquids, and as gases. So metals conduct electricity, period. End of story. Melting and boiling point. I hope you know this, but metals have very high melting and boiling points because of the type of metallic bonding. In this picture over here on the right, the metallic nuclei are kind of held together by this swarm of electrons that is delocalized. So the nuclei are actually really tightly packed into each other, and the cloud of electrons that travels throughout the metal kind of holds it all together. So therefore, they have high melting and boiling points. Crystal structures. Well, crystal lattice is what's called when we talk about the crystal structure in a metal. If you got a magnifying glass and any piece of metal out there and zoomed in close enough, you would see billions and trillions of little tiny little crystals of metal. You wouldn't see the sea of electrons, but that ocean of free valence electrons gives metal their shiny color and allows them to conduct electricity, thanks to photoelectric effect. But anyways, I digress. Compare and contrast, Venn diagram. Covalent compounds is always two metals. These are our rules of thumbs. They're always non-conductive, and they always have low melting point and boiling point. They are usually always soft. Ionic compounds. We always have a metal plus a nonmetal that formed ions and got stuck into a crystal. They are conductive in solution and as molten forms, but that's very rare. They have high melting point and boiling point, and they're typically very hard. Now, what do both of these have in common? Some of the simple basics. Ionics and covalents are both stable because they have full valence shells of octets of electrons, and they are all bonded compounds. So this is what they have in common. Okay, so there are 3 pages of practice based on the properties of metals, nonmetals, metalloids. Nope, that's wrong. Metals, ionic compounds, and covalent compounds. You're going to need a periodic table to do these pages and a Google Classroom assignment to back it all up. Thanks for watching. See you later.